So the first part, I'm going to talk about scatter plots. That's what we learned in our data science unit. And then I have 10 multiple choice problems for us to work through. And that's today's class. Scatter plots, okay, if you remember, they are graphing two variables on the x, or one on the x and then one on the y-axis. In front of you is an example scatter plot. If I zoom in, you can see the x and the y-axis. X here is boats registered in Florida, measured in the thousands. The y-axis is manatees killed. You notice there's a bunch of dots. Yes? And there's some patterns you can determine from here. From any scatter plot, we describe their direction, form, and strength. So in this case, is this scatter plot, what's its direction? Is it positive or negative? Good. It's positive because it points upwards towards the numbers, positive numbers like that. Okay. Is it linear or nonlinear? Good. It's linear. Looks like a line. And in terms of strength, I could draw a better line than that. Yes, if I drew this line, what's the strength? Is it strong or weak? Yeah, pretty strong in this case. It would have to be very far away for it to be weak. And in this case, I don't think we have any outliers. They're all pretty close together. And this graph is telling, or this scatter plot is then telling us, as we put it into context, as more and more boats are being registered in Florida, what happens to the manatees? The sea cows or the mermaids, sirens even in mythology. As people buy more and more boats, are there more manatees or less manatees? Yes, more are killed, unfortunately. There are less manatees, in other words. Okay? Very good. Go to clear the screen. And then the second part of scatter plots that we talked about is this idea of a residual. How do you draw the best line of best fit, right? Fancily called the least squares regression line. In order to do so, we have to know how off we are. And in this case, we have this new vocabulary word called residuals. And it is a measure of how far a prediction is from what Watt has actually observed. There we go. Mr. Chan can't spell. Some things never change. So the residual in an equation is actual minus predicted. Okay, simple enough, some subtraction. Here's a scatter plot, one that you may remember. On the x-axis here is number of months taking supplement. So think about that as months of eating some medicine. Over here on the y-axis is days cold lasted. And what's in front of you right now are the positive residuals. Your actual value is greater than your predicted value. Anything that's predicted is what your line of best fit says. So in this case, it's an underestimate. Under. You can spell that. Underestimate. It's a big word. Okay, when you have positive residuals, it is an underestimate. Because this person here was sick for, what, 5 days? But our line said they were sick for like 4.5 days. It's a positive residual based on this formula. As we go to the next one, these at the bottom of the line are negative residuals. So these ones, let's go with this one, for example, right? Your line says the person was sick for maybe like 3.8 days, but actually they were sick for 3 days. So this thing is an overestimate. your residuals are now negative. I have to spell the whole word. And when we draw our best line of best fit, our least squares regression line, it tries to find and minimize these residuals. And more specifically, it minimizes the squares of these residuals, because if we, there's this edge case where the positive and negatives cancel. When we square them, that's never the case. Area is always positive. Then the last and probably the most confusing idea that we talked about was this idea of an R. What is R? R is a measure of strength. It's defined as this complicated formula. And what we studied is that it's too complicated for us to do by hand, so we put it into a calculator or we put it into a program, like in Pirate, for it to tell us what the R value is. And it gives us a formal measure of strength. The correlation coefficient is defined as R, and more specifically, we interpret it as R squared. Okay, R squared is a measure of strength. So the one sentence frame I taught you was related to this. Oops. Okay, R squared expressed as a percent means that R squared percent of the variability in the dependent variable can be explained by a linear relationship with the independent variable. So the second paragraph, we see that, okay, you have this data on the amount of fertilizer versus plant height. You see that its R value is 0.6, so R squared is 0.36. That's 0.6 times 0.6. And so we can say 36% of the variability in plant height can be explained by a linear relationship with the amount of fertilizer used. That's how strong we can say, 36%. But of course, there's always other factors that affect plant height. Just think about water, amount of sunlight, soil, so on and so forth. It could explain why it isn't as strong as we initially thought, because there's so many other variables that come into play. Going back here to our days sick versus a number of supplements, when we look at this R squared value, it is 90%, right? Close enough to 91. So this line of best fit explains 91% of the variability in the data, right? It's pretty strong and negatively correlated. The number of months taking a supplement, that's your x-axis, that's your dependent variable, is strongly and negatively correlated with the days spent sick. That's your dependent variable. Y. Okay. The last part that we have to talk about is making sense of the problem in context. So that's looking at your slope and your y-intercept. When you draw a line of best fit, you have this equation here. We pay attention now to this part, the slope, and this part, the y-intercept. The y-intercept here is 5.37 for those that can't see this tiny number. And so what that means is that this number here, if you don't take any supplements, you don't take any medicine, then you can expect to be sick for 5.3 days, 5.4 days. Okay, that makes sense. And then as you take more and more medicine, it seems like you are more able to fight off this cold. You're spent less days sick. So then over here, let's find 1. Okay. So after taking supplements for 1 month, you can expect to be sick for a little bit less than 4 days. For every month that you take supplements, you can expect the day to be the days spent sick to be reduced by like 1.5 or 1.6. That's what your slope tells you. All right, questions on these topics: scatter plots, residuals, lines of best fit, R squared, and correlation coefficient? This is the hard part about teaching online. I can't tell if you're just thinking or You don't have any input. Right. Silence is compliance. So we move on to this next part, and you may want to have a little sheet of paper next to you. We have 10 practice problems related to statistics. They are all multiple choice. I've pulled them all from the SAT or the ACT, some kind of standardized test that you will take in the future. It's not likely you will see this in your math classes unless you are in AP Stats. And on the side over here, I want to write down some work so you can follow along, but the question is still going to remain on the left side of the screen. Those on mobile phones, you can zoom in. One student told me you can do that, so you can see the numbers a bit more clearly. And the rest of this class is just us working through these 10 problems. And for the students joining me now, when you type in your answer A through E, that's when I'll start to go over it. For some of the longer problems, I'll work on it alongside you, and you can see my writing on the right-hand side of the screen. Okay? Are you ready? So try to work through this problem. It uses the statistics ideas I've talked about this week, and then I'll slowly write out some ideas over here. Can everyone see the question okay? So while you're working, I'll be writing some things out over here. Okay, that was roughly a minute or so. You have your guess. You're more than welcome to type that into chat, but I will review the question now. So reading this bar graph that's in front of you, room 100 and room 206, those are the smaller groups, right? They have the fewest numbers of box tops. That leaves room 159 and room 215 to have the most number of box tops, and they wanted you to figure out the percentage comparing these two. Once you read your bar graph and added up those numbers together, you get 900 and 1800. Dividing that gives you 50%, so the answer to this first practice problem is B. One thing you may had trouble with is estimating. Notice the bar for room 206 is between 200 and 400. It's halfway between, so that's where we had to approximate 300 from. Ready for the next one? Here's your next one. Stats practice number 2. I hope you can see it okay. I'll work alongside you for this one. think it's Did you guys get some particular answers? Yes? Yeah, awesome, Melinda. So it is A. After you read these bar graphs and pie charts, it becomes a percent problem. The math behind it is finding 15% of 2,500, which is 375, so the answer here is in fact A. Not so bad so far. We talked about representations of data. Here are some different representations of data. Here's your third one. A little bit more complicated now. We're talking about mean and median given a histogram. I'll give you all another minute. This one does involve a bit more thinking and strategies to approach it. If anything, on the standardized test, you would take a guess. The SAT and I think the PSAT too no longer give you a deduction for having wrong guesses or wrong answers. When I took the standardized test like the SAT, by guessing, it actually brings down your score, so sometimes you would leave things blank. But that's not the case for you. You have it better now. Another 40 seconds. If anything, guess A, B, C, or D. Yes, very good. Just guess. Okay, so this one, it becomes a little complicated. We have to know how median, mean, those two measures of center, how they fit into a histogram. And the problem, they kind of remind you that histograms have this range. So we can't find like 25, for example. Who's the specific worker that worked 25 hours? This histogram doesn't tell us that. It just tells us that there are 17 workers that worked between 20 to 30 hours. But there's still some order, so we can still figure out stuff about the median, and there's still some numbers here, right? All the numbers are in fact represented, so we can figure out where the mean is. Okay, I'm gonna make this part a little bit bigger so we can see over here. So I'm going to add in some lines to make this a bit more clear. What's nice about this is it's already sorted. So I add in these lines. This each represents one person. Okay, and after I add all these lines, there should be 40 boxes total, because the problem told us there were 40 total workers. And you'll see that once I have all my people now represented on the graph with purple lines, because they're sorted, we can now start eliminating things. What do I mean? Well, if we cross off, let's say in red, right, these two people and these two people, we've just eliminated the smallest number of hours worked and the two largest number of hours worked. It's just like having a list of numbers out like this and then canceling like that. This is how we do so on this histogram. So we continue that pattern. There's another one, goodbye. There's another 3, there's 3, there's 2, here's 2, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then we keep going up, blah, 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 blah. At this point, we don't really need to continue these other cancels, right? Here's our median. Does that process make sense? On a histogram, this process is very similar to what we did like this on numbers in an ordered fashion. So now, Nikki guessed that there was A. It could be. We don't know for sure our median in this case, right? We just know right now, since it's in this column, that it's somewhere between 20 and 30. So all these medians over here that have that is between 20 and 30 are potential right answers. Right now, D we know is definitely incorrect based on this calculation, or this crossing out. Then the next part. From a histogram, we can also determine the mean. From yesterday, you can imagine that, how would I draw a shape? How would I fill it in? Okay, so temporarily, let me just highlight. Pretend this part of your data isn't here, right? Just for now. You would have a curve that looks like this. Okay, kind of. So you know that your mean would be somewhere here. But when we add back in all this stuff, right, our curve now became more like this. It's skewed right. So your mean, because it's not sensitive to this set of outliers, was here, but now it's going to get shifted over. It's going to want to move somewhere over here, away from your giant peak. So using that thought process, there's our mean, somewhere between 30 and 40. The only answer choice that matches that would be option C. Mean has to be between 30 and 40. Does that reasoning make sense? I think this is one of the harder problems involving mean, median, mode in statistics. In your standardized tests, you'll have some easy, some hard. Here's an example of a harder one. So in the first class, my answer key didn't say C, it said D, or something else. My answer key was wrong. So we did the same amount of work there, but I was more able to illustrate it the second time around. Here's your next question. Some quiz scores, similar to the examples I showed you yesterday. So take a minute or so to think about these. So this is now our fourth problem. 10 total. You had some time to think. If you're stuck, just give it a guess. You have 25% chance of getting it right. So for this problem, it mentions standard deviation, and here we have a box plot. For standard deviation measures spread. And visually, looking at class A versus class B, which one has the more spread? Which data points are more spread out? Is it class B or class A? Okay, you stared at it. I hope you say class B. It's more spread out. Think about like peanut butter and jelly. You wouldn't want it to have giant clumps like it did in class A, where part of your sandwich has all the peanut butter, right? You want to make sure it's even, so that one has greater spread, yes? So that's why class B has greater spread. And the sentence that matches that is in option A. The standard deviation, otherwise known as the spread, of quiz scores in A is less than the spread in class B. Class A has a smaller spread of its data. A. Right? These next one, you may want a piece of paper next to you. This is finding the average. Think about it for maybe another 40 seconds. Okay, so for this problem, it involves a little bit of algebra. A, B, C, and D, all that means is that being integers means that they're whole numbers. A is less than B is less than C is less than D is less than E. It just says there's some order there. It allows us to make the following equations and then the following substitutions. So B equals the average of A and C. So we add up A and C and divide by 2 because there's two numbers. For D, it's the average of C and E. Because there are two numbers, we divide by 2. And we're interested in the average of B and D. So it's B and D. Be careful, don't stop there. After adding them, you have to divide by 2. So together, this represents the average of B and D. Otherwise, you'll get a different answer, which is one of the answer choices. It's one of the wrong ones. So from here, we make a little substitution. A plus C divided by 2 plus C plus E divided by 2. All of this over 2. We'll add fractions along the top. We get A 2C plus E all over 2. Notice that's the numerator of our big fraction, and we divide that by 2. We have fractions and fractions. It may look intimidating, but you can rewrite it. A plus 2C plus E over 2. when you divide by 2, it's like multiplying by 1/2, and suddenly it's a less scary problem. We get a final answer of a plus 2c plus e all over 4. And you can tell me which answer choice that matches. Yes? This matches answer choice E. So far, so good. So this is the 5th out of the 10 SAT practice problems I'm doing. They're all multiple choice. If you want to have out a piece of paper, it's going to help you so you can follow along. Here's number 6. The average of these things equals, oh shoot, did I get cut off? Where'd it go? Okay, it's supposed to tell you that the average, oh darn, okay. I mess up this question. Okay, m plus n plus p is 8. If n plus n equals, oh, it all fits. Okay, equals 15, everything's there. Then what does p have to equal? So set up the equation. Give you 40 seconds. It's hard to tell if I'm going too fast or too slow. I'm not getting any feedback. Okay, so for this problem, you translate these things into words. Again, using what we know about mean or average, the equation looks like this. Don't forget to divide by 3, equals 8. The next part, it tells us about m plus n. It tells us that sum is 15. Now it becomes an equation we can solve for. When you get undo and you solve for p, 15 plus p equals 24. So then subtract 15 from both sides, p equals 9. And that matches option D. Good job. Yeah, be careful with these. The SAT is really good at having all the other answer choices here. So it makes you second guess yourself, because if you made a mistake, they have that answer represented. And the worst part, they even have like 5 answer choices for you. So that reviews the mean, also reviews some algebra, translating it from words into equations, using some substitution. There's question 7, a shorter one. Cool. Remember, when calculating the median, you have to sort your numbers first. So if you thought it's just some canceling and you guessed 97A, that's one of the traps. It's wrong because you forgot to sort. So in this case, you'll see that once I have it sorted, 1, 2, 7, 22, 52, 97, 100, and I start crossing off some numbers, one from the left, one from the right, we see that our median here is 22, which matches answer choice E. Okay, that's when the median, you have an odd data set. There's just one number in the middle. This next one, it should go over having more than one number in the middle. So there's a table of the high and low temperatures each month for Michigan. Which one of these is the median? Which one of these are the median values? I'll do this one alongside you because it's going to take me a while to sort these 12 numbers. Can you see them okay? Anyone get some medians? Okay. So at this point, I hope you're working through it. You've sorted your list, and you're crossing off some numbers, and you see that there are 2 in the middle. So remember, when you have 2 numbers in the middle, take the average of those 2 numbers. For the ones that I showed, I did the low temperatures. I sorted them first, and it could take some time. As I cross things off, you see that I get 50 or 35 and 39 as my 2 center numbers. When you divide them, when you add them up and divide by 2, you see that the median for the low temperatures is 37. As I scan my answer choices for just the lows, you see that B is the only one with 37 as an answer choice for the median. So that's why it has to be B. And you don't have to calculate all the other ones. Okay. Awesome. B is the correct answer. Two more, just about there. Stats practice number 9. This is the one that kind of got cut off. The average of 179 and some number n is -1. What is the median of this data set? I got a little different number because, check your arithmetic. I think the answer here is 4. Which is A. Yes, watch the positive and negative signs. Yes, I think that was your mistake. So in the beginning, you have to be careful. I think a very easy error to make is with this one, right? Forgetting the 4. I'm not sure how one would get positive 1. So after you solve for n, remember to sort your list. In this case, when we solved for n, it was negative 21. So it begins at the very end. N is not included. So then you take the average of 1 and 7, which is 4. Last one. Your only question involving mode. Okay, last one. You figured out the mode. You're looking at the median from an odd numbered data set. You see that John has to be which letter? Which student? Okay, a complete guess. Okay, 20% chance of getting it right because we have 5 choices here. Any other guesses? Nice. Student here, student B is in fact who John is, because he's the one that has the test score 1 of 85, and the median is for test score 2 is 80. So that's B. So there's your practice. Last optional lecture. If you, oh, you thought 85 was greater than 80. Yes, yes. Be careful. The numbers do look sorted, going off test score 2. Yes, so be careful. Next week, be sure you are checking in with your teachers for the distance learning schedule. I'm going to see you all, yep, because none of you are in my reg, all of you on Tuesday, or I'll hear from you on Piazza. Please make sure your Piazza is working. If not, send me an email. We'll get your password and account set up. And tell all your friends on Tuesday to check Piazza, check their email. Take care, everyone. Enjoy the weekend. Enjoy the sunshine.